Yes, I will talk about another potential raw material for lithium, and that is recycling. So, little bit recycling of discarded lithium-ion batteries and the challenges with that. We had short projects in this, trying to use only thermal options, pyrometallurgy, to recycle it, with the ambition to recycle the alumina, cobalt, copper, and also lithium, which we realized after the project ended that that was very difficult. But I think you have been touching it with this predicted increase in using electrical vehicles. There will also be then a great demand of, for example, lithium, but also other metals, as you were talking about, cobalt, nickel, copper, alumina, etc. So there is, with the new technical and electronic devices and vehicles, a demand for these metals. And what one can see is also that, there is the pointer. If one look at the electrical car stock from 2005 to 2015, it's been a big increase, and still it's almost or less than 1% of the car on the markets. So if we are going to change our transport sector into electrical vehicles, the demand is tremendous. And what is also is, of course, when you produce and you develop battery chemistry, you are often looking at other things than that it should be recycled, because you need it. This is not my area, so I will just, I have no idea about this, but you need high specific power, energy density, and of course lifetime. And that is what drives the development of the battery chemistry. So one can see that it is changing a lot during the years, and that is, of course, a big challenge when you come to recycling. Because if you have a mineralization in ore, I think you know a bit better than what we know about how the composition is. This is from what we know today. And today still there is a lot of number of different batteries and a number of different compositions. So already today there is a number of different composition, and we don't know what the future will have. But it consists of a cathode, which is a lithium metal oxide, and you have other metals like cobalt, nickel, etc. You have an anode, which is usually a graphite, and a copper foil as a binder. You have the electrolyte, which is usually lithium salts. And you have, of course, the casing, electrical conducts, which consist of both plastics, and you have steel, alumina casing. So it is quite a complex composition. And that is, of course, a challenge. And usually I see scrap is a little bit like a mineralization. You need to find out whether it has an economical potential to be recycled, both technical but also economical. And then there is also a cost, not only in money but also energy. What kind of residues, waste will you produce from extracting metals from scrap? Today, many of the lithium-ion batteries contains cobalt and nickel, and that is expensive metals. So with that content, it can be economical to recycle it. But one can also foresee that the amount of cobalt, especially cobalt, is decreasing due to the cost. So will it then be economical to recycle it? Of course, you were talking about that the lithium price is increasing and can be predicted to increase further. So then maybe there will be potential to find solutions to recycle the lithium. You also have the safety issue in recycling of lithium-ion batteries, to not having explosions when you recycle them. And of course, this is just a few examples of the batteries composition today. You have the lithium, nickel, cobalt. You have those ones with lithium, iron, phosphate. And from a recycling point of view, it will be quite different processes for these. And what today is, you should of course have some kind of pre-treatment. You can have mechanical processing, mineral processing techniques, hydro and pyrometallurgical processing. And I was trying to find out, I know that Umicore is recycling lithium-ion batteries today, and it's the one containing cobalt and nickel. I was trying to find out, Toxco is a Canadian or developed in Canada. I'm not sure if it is in commercial use today. In Japan, they have the Sony Sumitomo process. I took these three as examples because they are quite different processes. What Umicore is doing is that they use a smelting process, so they charge the battery to a furnace, and they by smelting they get different phases, and they produce a metal alloy which is then further treated to recover cobalt, nickel, etc. Lithium ends up in the slag phase together with alumina, manganese. So today the lithium is not extracted as a lithium metal. The Sony Sumitomo process is based on incineration at 1,000 degrees. Get the fly ash where the lithium ends up in, metals and a powder. And the last one is the Toxco process, which is based on a hydrometallurgical way. So you have a cooling in liquid nitrogen, shredding, and then a hydrometallurgical process to extract, and it's the lithium they are extracting from this. I think I'm ready now. And just coming to my last question, what I think and what I liked when I also heard your presentation, for me a little bit, it's about the combination of primary and secondary materials. Scrap is just an additional material for potential extraction of metals. And in some cases, of course, you have dedicated processes for scrap, but many times you have them integrated with the primary concentrates. I think one needs a combination of different processes, mineral processing, hydropyrometallurgy, and also to look at raw material streams going into existing processes to find the flexibility. And also what is not so often talked about is the design for recycling. Thank you.